2.2 trig ratios with obtuse angles. So first we're going to talk about standard position, and for the scope of this course we're going to put all of our angles in standard position, and this is when our angle is situated that the initial side is laying right on the x-axis if we're talking about a Cartesian plane, okay, and then the angle goes up to some terminal arm, okay, and it rotates counterclockwise. Okay, so all of our angles are going to rotate this way. Okay, so angle measured on the Cartesian plane, this in here would be the angle. Okay, and measured counterclockwise about, okay, that's how we say it in mathematics, about the origin from the positive x-axis. Okay, so this would be an example in quadrant 1, which would be acute, and this is an example in quadrant 2, which would be obtuse. Okay, this angle that we're dealing with is still this one. It's from the positive x-axis to the terminal arm. Okay, for any angle theta in standard position, these relationships are true. Okay, so whatever the x comma y value is, we're going to have sine theta equals y over r. I'm going to get to r. Cos theta is x over r, and tan theta is y over x. Okay, the r value is going to be, and I have it here, but this is Pythagorean's theorem rearranged. So instead of having the c, we have radius, and then it's rooted. Okay, because just remember, wherever your point is, say you have a point here, this would lie on the radius of that circle. Okay. So please note, in quadrant 1, all sine, cos, and tan, oh, I should put it over here, let's use green, sine, cos, and tan have positive ratios. In quadrant 2, sine is positive, but cos and tan are both negative. And we're going to get to that and how to apply it. Okay, example 1, acute angles in standard position. So determine the primary trig ratios of the angle in standard position with the terminal arm passing through 0.43. Okay, as soon as I see this and I see a graph, I'm thinking, let's plot that. Okay, standard position would be, this is the initial arm and this is the terminal arm. So this is going to be our theta. Okay, round your answers to 3 decimals. So we draw a triangle. It's a right angle triangle. If we look at the x-axis, we moved 4 units. If we look at the y, maybe the y value, we moved 3 units. And then we have to solve for r. So just like Pythagorean's theorem, let's go ahead and solve for r. So 4 squared plus 3 squared equals c squared. C could be r, that's fine as well. We can change that to r. So 16 plus 9 is the radius squared, 25 is the radius squared, and then we can root. So r equals 5. So our r value is going to be 5. Now, this question asks us for the primary trig ratios. Okay, ratios, as a review, there we go, is going to be over here. This is the angle. This fraction is the ratio. When you think of ratio, you should think of fraction. Okay, and then we're going to round our answers to 3 decimals. Okay, so for sine, we're looking at opposite over hypotenuse. We have opposite here, we have adjacent, and we have hypotenuse. So we get 3 over 5. Which is 0.6. For cos, we get 4 over 5, which is 0.8. And then for tan, we get opposite over adjacent, which is 3 over 4. So 0.75. Okay, obtuse angles in standard position. So we just drew an angle and it was in quadrant 1. Now we're going to deal with an angle in quadrant 2. Okay, so let's go ahead and graph -4, 6. So -4, 6. Okay, this is going to be our terminal arm and our initial arm. Now let's join that with the triangle. It's right angle and this in here is going to be our theta. Okay, we have the value of 4 here and the value of 6 here. We need the radius. So let's go. A squared plus b squared equals c squared. In this case, we can substitute our 4 and substitute our 6, and we're going to get the radius squared. So we have 16 plus 36 is radius squared. Okay, so it's going to be 52 equals radius squared. And then if we square root both sides, we're going to get 7.2 for our radius. Now let's go ahead and label the opposite, the adjacent, and the hypotenuse. So we'll do sine theta, cos theta, tan theta. This question asks us to determine the primary trig ratios of angle theta to 3 decimal places. So for sine, we're dealing with opposite over hypotenuse, 6 over 7.2. We're going to actually have to calculate that in our calculators. I get 0.833. Okay, for cos, we're going to do adjacent over hypotenuse, so 4 over 7.2. And we get 0.556. And for tan, we're going to go opposite, 6 over 4 over adjacent. And I think that's 1.2. Oh, 6 over 4. Sorry, 1.5. That's it. Okay, here is what is missing. In this quadrant, and this was at the bottom of the notes, in this quadrant, sine is positive, cos is negative, so we're going to have negative 4 over 7.2, or negative 0.556, and tan is negative. So either negative 6.4 or negative 1.5. Okay, so this question, example 3, we're looking at trig ratios of supplementary angles. So we're going to compare the trig ratios of the angles whose terminal arms pass through these 2 points. So let's do this one first. We get 4, 5. Plot the point, draw the terminal arm, draw the initial arm. We're going to draw that triangle, okay? This is theta. This is 4 units, this is 5 units. Let's solve for the radius. So we have a squared plus b squared equals, let's do r squared, 4 squared plus 5 squared, 16 plus 25. We get 41. Okay, 41 equals r squared. We go ahead and root both sides. We get 41 square root. We get 6.4. Okay, so when we do the 3 primary trig ratios of this one, I'll put them down here. We get sine theta is, label opposite, 5 over 6.4. Cos theta is 4 over 6.4. And tan theta is 5 over 4. Okay, let's do the same thing, but let's do it with the second point, negative 4, 5. Okay, so negative 4, 5, we're going to plot our point here. We're going to draw our terminal arm and our initial arm and draw that as a triangle. We have 4 units. We have 5 units. Okay, this is opposite. This is adjacent. This is hypotenuse. Here's the thing. If we plug in the 5 and the 4 into the radius formula, which is just Pythagorean's theorem, well, 5 and 4 are the same thing. These two are going to be equivalent. So we're going to have a radius of, I'm going to skip these steps, we're going to have a radius of 6.4. Now, if we did sine theta, cos theta, and tan theta, we're going to get 5 over 6.4, 4 over 6.4, and 5 over 4. If we notice, the ratios are exactly the same. Okay, until we take into account that this is in quadrant 2. So in quadrant 2, cos and tan are negative. So we have the same number for the ratio, 4 over 6.4, 4 over 6.4, 5 over 4, 5 over 4, right? But for quadrant 2, the cos and the tan are negative. That's the comparison.